Okay, let's kick it off. Welcome everyone back to our 13th call this time. If you're new here, some context. We are having these calls with core contributors every month. The purposes of these calls are for core contributors to present what they've been working on, leverage the cross-functionality introduced by the different working groups to brainstorm new ideas and research tracks, and also get community feedback on some of these work streams. I'll paste in the chat and show notes a link to the Graphs ecosystem calendar, which you can use to be subscribed to future calls like these, as well as community talks, which are now being taken over by the advocates now. So before we start, I'd just like to mention two amazing events that are coming, that are all about Web3. It's pretty cool. Graph Day, 2nd of June, that's coming. It's a full day where you'll get to hear from leading protocol and developers building this space. You're definitely not going to miss it. Wave 2 tickets are still available, so you can head on to thegraph.com, click the Graph Day link on top, you'll find it there at the menu, and yeah, there will be a link for you to get your tickets. On GraphHack, this is a 3-day event that's following up by Graph Day. It's a hackathon packed with amazing workshops, even for those who are not hacking, really. And but if you are, actually, there are almost 400K in bounties from our different sponsors. So that's a nice incentive right there. And if you're coming, you'll always have the chance to talk to the Graphs core developers as well and do some great work there. Okay. About this call today, I do have some topics. We can start with, as a follow-up to the latest core R&D sync, we'll hear from Craig, Edge and Node, on what the recent GIP 30 is all about. I believe Brandon is also on the call, so we can get some context here. As a quick recap, this is the resulting work of Edge and Node and data team and the Prism's analysis of the critical vulnerability disclosed in a protocol audit by OpenZeppelin, which we've now open sourced, and I can also share some links here. Next, from the Indexed Experience Working Group, we'll have Annie from Semiotic presenting the recent efforts around the automated allocation optimization tool, as well as a new framework that's brand new, but we'll get a quick intro, I think, on Graphsim. This might be of interest to indexers, but rather not just indexers, but everyone else who wants to quickly simulate, test, and study any modifications to the protocol's mechanisms. And then to wrap up, we'll finish with the Data and APIs working group. Adam will walk us through the Hardhat plugin. We have a thread on our forum. I can also link it there for some context. This is in the works, and so we'll consider some updates here, as well as the block oracle, which is pretty important one. That's the solution that might unlock, or that will unlock, multi-chain indexing rewards on the network. So that's it from my side. Let's get started. Brandon, Craig, do you guys want to talk a little bit about GIP 30 while I share in the chat some links?
Sure, yeah, I'm happy to tee it off really quickly. I think you did a great overview, but yeah, as Pedro said, the work in GIP 30 kind of started over a year ago with the OpenZeppelin audits. There were a couple unresolved vulnerabilities identified in that audit that required economic analysis, not technical analysis, to determine whether or not the vulnerabilities were legitimate. The foundation gave a grant to Prism Group about a year ago to take a classical economic approach at looking at these vulnerabilities. One of them, which was called delegator front running, they sort of identified out the gates that the protocol just wasn't vulnerable to it from an economic perspective. The other one, which was called POI spoofing, was disclosed like a month or so ago, and that did have a recommendation attached to it, which was this minimum signal. So Craig, Ricky, and the data science team at Edge and Node did a really great analysis to kind of shed light on some of the pros and cons, and also figure out some of the considerations when choosing the right parameter for minimum signal. And I'll let Craig go deeper into that. But one thing I just want to call out is that this proposal will be a regression for some subgraphs in the network. So there will be subgraphs that in theory are eligible for indexing rewards today that would not be eligible for indexing rewards after this proposal goes into effect, which would mean that very likely any indexers on those subgraphs would stop indexing them. We believe that the threshold that we've chosen minimizes impact to any subgraphs that might be being used in production. Because this is a security recommendation, this isn't something that we're necessarily looking for a yes or no vote on, based on sort of subjective preferences, but we did want to disclose this before the upgrade to leave enough ample time for comment periods if there's any concerns that should be incorporated into the analysis. So with that, I will kick it off to Craig to go a little bit deeper into what's in this proposal and some of the pros and cons.
Cool, thank you, Brandon. Yeah, so I can just give a TLDR on the GIP initially, and list some of the pros and cons. And yeah, if we have a little time afterwards, we can open it up for questions. Yeah, so as Brandon mentioned, Ricky Escalopon, my colleague, did a lot of interesting work that did a parameter search over the parameters identified in the PRISM model as influencing the profitability of this attack. So for background on the attack, yeah, indexers could theoretically provide spoofed POIs, so invalid POIs, and also minimize their self-stake, which is at risk of slashing, and maximize their self-delegation, which is not at risk of slashing. And theoretically, it is possible for it to be profitable for them to collect indexing rewards and you know, have, since there's less value at risk of slashing, then even if they were to be slashed the maximum amount, you know, the indexing rewards would still exceed the negative expected value of slashing. So they have a formal model that has a number of parameters like slashing risk, slashing rate, max delegation ratio, etc. So we did a parameter search over all the values of those and identified that in their model, the biggest factors influencing the profitability of the attack were the difference between honest indexer costs and dishonest indexer costs. So honest indexer costs are things that, you know, are specific, like are specific to people who are actually doing the work of indexing. Whereas dishonest indexer costs are, you know, you can think of it as the cost faced by both honest and dishonest indexers. In that, you know, a dishonest indexer would have these costs, and, you know, so things like gas costs and, you know, the minimum hardware costs just associated with submitting a POI in the first place as a spoofed POI. So honest indexer costs would be like, you know, things associated with like actually indexing subgraphs. So the biggest, probably the biggest insight from the analysis is that on a per subgraph basis, the honest indexer costs are not super high right now because you can serve many subgraphs from the same hardware. So on a per subgraph basis, the infrastructure costs are not super high. And the majority of cost is gas costs from the allocation, opening and closing allocations. And that's faced by both honest and dishonest indexers. So that really helps us in coming up with like less invasive like values for parameters that would protect against this attack. And in particular, we thought the best one was minimum curation signal. And the idea here is that if you increase the curation signal, that is going to make it rational for more indexers to enter and pursue the indexing reward. The indexing rewards will be higher, and more indexers will enter the market. That will create more competition and bring down the profitability of spoofing. So yeah, we looked at parameters that would satisfy the zero profit condition that Prism came up with under different conditions. And 500 GRT seems to be a good one that would protect against this attack and some pretty adverse conditions. Yeah, so that we have some charts in the forum post, but yeah, with this, with 500 GRT, it meets the no profit condition under an economic situation where the annual opportunity cost of capital is 22% or less, and with a GRT, like a very conservative, assumption for GRT price at an all-time low of 10 cents USD. Yeah, so further, if we were to increase the GRT price or decrease the opportunity cost of capital, those just make the attack less viable, and then also decrease, the minimum signal that would be required to protect against it. So yeah, that's the situation. And the trade-offs here are, of course, that having a minimum curation signal to qualify for indexing rewards creates more friction. It reduces the likelihood that a subgraph would be picked up for indexing for anything with less than 500 GRT signals. So it creates a little bit more friction for subgraph developers who would not be signaling over 500 GRT or wouldn't be able to track that. Ricky has since done some analysis that shows that that's a very small number of subgraphs, and as far as we know, none of those subgraphs with less than 500 GRT are being used for production traffic. That could be wrong, but definitely most of the vast majority of subgraphs being used for production traffic by developers have over 500 GRT. So it would not be, it wouldn't be a ton of subgraphs affected here, and definitely almost surely none that are used for production level traffic. So but the benefits are it's a best effort mechanism to mitigate against the attack identified. And I think, the even bigger benefit, perhaps is that we were able to open source these audits, give the community more information about the economic vulnerabilities. This also, just increases the transparency and gives the community the ability, the tool to address this attack based on, and make an informed decision based on the weighing the risks and the trade-offs here. So yeah, we just wanted to provide the community with as much information as possible to, so we can make a good decision here. So happy to answer any questions associated with the analysis or the trade-offs.
Yeah, just to underline one of the last points that Craig made, a lot of DeFi protocols that have looked at incorporating the graph, integrating with the graph, this has been one of their biggest asks, was having these audits open sourced. And so that's been kind of a blocker on getting some of the DeFi composability benefits of, the graph being on the same L1 with all these other DeFi protocols. So that's something I think we're really excited to sort of unlock. Another call to action here is this may feel like a really small outcome for about a year's worth of like analysis. We're just basically setting this minimum signal parameter, and and sort of, now the attack is generally considered mitigated. But I would emphasize that a lot of really good sort of precursor research had to go into even getting to the point of being able to do this analysis. And so even if you're not interested in like this specific change, I highly recommend looking at the posts that Craig and Pedro published to the forums, because they include a general equilibrium analysis by Prism of like the entire indexer market in the protocol. Even in the spoofing analysis, there's some like really interesting general results. Like if you look at the appendix of the spoofing analysis, there's a proof that relates the number of unique indexers on a subgraph is kind of being proportional to the square root of indexing rewards over the fixed costs of indexing. And we've managed to sort of verify that both empirically and in simulations that relationship seems to hold. So a lot of really good nuggets of insight, even just in the process of getting to the point of being able to put these proposals together. And then obviously there's the outcome of being able to, plug this security hole and sort of unblock the protocol for some of these DeFi opportunities.
Totally. And I think a lot of the Prism work will be able to, generalize from, and use some of the formulas as Legos for subsequent analysis or mechanism design. So a lot of that stuff is reusable.
Quick question, guys. Jim here.
Yeah, absolutely. I just linked the preceding work on the chat.
Am I right to go ahead, Pedro? Just ask a quick question.
Yeah, sure. Sorry, Jim, I couldn't hear you.
First of all, I've said it before, but the level of rigor in this analysis has been really enjoyable to read. So thank you, Craig, and thank you, Ricky, for the work you've done on this. Just one question, which is sort of ancillary. When this is being when we eventually upgrade for this change, are we doing something on the UX side as well to make subgraph developers aware of this minimum requirement if they want indexing services from the get-go?
Yeah, it's a great point. This is something that we should, this call is, I guess, part of that process, but this is something that should be widely communicated out to the various dApp front ends. Obviously, the dApp front end that EdgeNode manages or develops is aware of the change. Fortunately, the change is backwards compatible from a technical standpoint. So like none of the interfaces are changing. No transactions are going to revert that previously would have succeeded. But certainly from an informational standpoint, we'll want to make sure people know that, hey, if you're signaling below 500 GRT, it's not worth it. I think we also already surfaced, at least in EdgeNode's Graph Explorer and Studio, if I'm not mistaken, whether a subgraph has been like disabled for indexing rewards due to the Oracle. And so we could maybe even piggyback on some of those like informational callouts that like, hey, because this is below the signal threshold, it's ineligible for indexing rewards.
Great, thanks, Brandon.
Yeah, it's a great point, Jim. And also thanks for sharing this on Discord to make sure we get the proper attention. All right, I think we should move on. So the other topic we've had was Graphsim and the work that Semiotic has been doing. So Annie, I'm not sure which one you want to get started with, but as an intro, I think it would also be worth talking about the DevConnect event and the workshop on incentive mechanism validation, or the WIMV as we're calling it. I think that ties in nicely with the efforts you guys are, or the work you guys are doing around Graphsim, right?
Yeah, that sounds like a good plan. Let me share my screen.
Oh, nice.
Cool. Just making sure you can see.
Yes, we can.
Perfect. Yeah, morning, everyone. So just going to chat about a couple topics like Pedro mentioned. Firstly, we'll talk about the DevConnect event, and in particular, the workshop on incentive mechanism validation. And then we'll also talk very briefly about Graphsim, which is a simulation effort that we're putting together, as well as an allocation optimization tool for indexers that we've been working on. Cool. So the workshop that we put together in Amsterdam was basically dedicated to the practical application of optimization, control theory, and reinforcement learning, just basically agent-based modeling techniques for the development and validation of Ethereum protocols. And it was held on the 18th of April as part of DevConnect in Amsterdam, and we had approximately 50 people attending. And there was a good mix of people who attended in terms of investors and founders, builders, students, developers, ML people, economics people. So quite a variety there. And then we had speakers from Edge and Node, Semiotic, LivePeer Protocol Labs, and the Ethereum Foundation. And the slides and videos will be posted at this website, so www.wimv.dev. Although they're not up yet, as per my understanding. So hopefully those should be up soon. So skipping ahead to the takeaways from this, it was generally a good networking event, but some of the feedback that we got were that there were just too many talks, especially if you think it was Monday, a lot of people flying from the US or flying from Australia, East Asia, India. All of these people were jet lagged, and by the end of the day, people were sort of exhausted. And on the first day to have that many talks was maybe not the best idea. Also, with respect to that, I think some of the feedback that I received when I talked to people was that the breakout sessions that we had as part of the second workshop, not part of the WIMV workshop, were so far late into the day that people by that point were tired. And couldn't really actively participate just because their brains weren't functioning. And Ariane actually brought up an interesting point in a previous discussion, which is that in these breakout sessions, people came up to him and basically, after 7 hours of us chatting, they started to ask questions like, what's a subgraph and what's an indexer? Which is, that's probably something we should do a better job of explaining up front so that there aren't those questions so far into the conversation. There were also a lot of interesting case studies, but people wanted things that they could take away and actually implement or use themselves. And a couple of the people that I talked to felt like that was sort of lacking, like they learned quite a lot about problems within the graph or problems within LivePeer, but they didn't know how to take that and apply it to problems within their own domain necessarily. So we can probably improve something there as well. And then there's also a request for new tools to enable mechanism research, which brings us to Graphsim, which is a new technology sort of that we're developing, where we're trying to containerize the entire graph protocol, everything from the indexer agent all the way through the smart contracts. And part of this is so that we can use this as a tool to test changes to the protocol and be more confident before we enact them. Part of it is also so that we can, test new PRs and stuff like that, not just sort of mechanism changes or GIPs or something, but just PRs and bug fixes and see whether they'll break something. But there's also probably some use to the broader community in this tool in terms of using it to better understand what they should be doing within the graph. So we're still in the very early stages of this, so nothing concrete to share with you guys yet. But yeah, hopefully we'll have more updates for you guys on that in the coming months. And I think that's all for this deck. So were there any questions on that before I move on to the allocation tool?
I just wanted to add on the workshop in DevConnect, that one thing that was really cool about this is, it'd been a few years, thanks to COVID, since a lot of the researchers in this space have kind of gotten together in person. And, 2-3 years ago, a lot of these different ecosystems, whether it was LivePeer or, Barnaby at the Ethereum's Robust Incentives Group. We're in like the very, very early stages of applying these sets of techniques like optimization, agent-based modeling, a lot of the stuff that Semiotic has brought into the graph ecosystem. And it was really, really amazing to see that like a lot of really talented teams had converged on the same sets of best practices and were, interested in exploring the same sets of tools. Filecoin's Crypto Econ Lab, which is I think less than a year or two old, was also there presenting on their simulations and their experiments. So, it really feels like the graph ecosystem is kind of at the forefront of this, developing this new set of practices. And so it's exciting to see kind of Graphsim and the stuff that I guess Ani is about to show next, added to that list.
Definitely. I totally agree with all of that. It was, I think one of the interesting things that came out of that workshop was seeing also, not just that we've converged to the same tools, but that we have a lot of the same problems. And so there's probably a lot of room for collaboration or more open discussions between all these different protocols. Any other comments or questions before we move on? Otherwise, I'm happy to jump forward. All right, let's do it. So let's grab this PDF. Cool. So the indexer allocation optimizer. So this is a project between within the indexer experience working group, but it's primarily being worked on by myself, Hope Yan from Figment, and Howard Heaton from Edge and Node. And we're sort of at a stage, as you'll see. I want to like more concretely define what we mean by optimal, because there are some caveats to that word. But we're also not at a stage where I would yet recommend this to indexers in production. I think there are a few bugs that we need to iron out first. So we're hoping to do that in the coming weeks. So the motivation is really just a way to provide indexers with a tool that allows them to allocate optimally with respect to indexing rewards, right? So a couple things to note on this slide. We are talking about indexing rewards. We're not considering anything about query fees in this optimal allocation tool. And then, like I said, we'll also have to dive into the word optimal a little bit to make sure that indexers understand, what we mean by optimal. So just a brief overview for people who haven't seen the indexing reward before, and also an introduction to the notation that we're using. So an indexer I is going to spend gas G to allocate stake omega ij out of its total stake sigma I stake to subgraph J. So lots of words there. If you ever forget the notation, let me know, and I can jump back real quick. Subgraph J has psi j token signaled on it, and indexer I receives an indexing reward R sub I based on its allocations and the issuance. And it's given by this formula here, where essentially we have two terms, right? The second term, the phi times the psi ratios, is basically the issuance times the ratio of how much signal is on subgraph J versus how much signal is on all subgraphs. So it's basically the proportion of the issuance that's on a particular subgraph. And then the first term, the omega ij term, is basically how much indexer I has allocated to that subgraph versus how much all other indexers have allocated to that subgraph. And then you just sum that over all subgraphs and you get indexer I's rewards. Okay, so in the optimal allocation problem, essentially what we have is a minimization problem. Technically, it's a maximization problem, right? Indexers want to maximize their reward. But if we make it negative, then we can just say, it's a minimization problem instead, and that allows us to use sort of normal convex optimization techniques. So we're going to minimize the negative indexer reward, subject to the constraint that the sum of the indexer's allocations equals their stake. What this does mean is that this tool will allocate all of an indexer stake. It won't leave a single GRT on the table. And then also subject to the constraint that the allocations themselves must be positive, which is just, understandable. And like I said, this is a convex optimization problem. So it's quite nice because we can use sort of these normal convex optimization optimization techniques. So just a brief introduction to convexity in case you've not heard that term before. So a convex function is just a function that has one global minimum and sort of one point in a sense where the slope is 0. And so to find the minimum, all we have to do is follow the slope, right? So intuitively, you can think about a ball rolling down a curve. In a convex function, the ball is guaranteed to end up stuck in the same place, no matter where you start from. In a non-convex function, the ball can get stuck in a lot of different places. So if you look at the figure on the right, if we start the ball where it says saddle point, the ball is not going to move left or right. It's just sort of going to stay there because there's no slope to drive it in either direction. Or if we start on the far left of that curve, it's going to end up stuck in what's the local minimum instead of the global minimum on the far right of that. Whereas if you look at the convex plot on the left, no matter where you start, you're always going to end up in the same point. Okay, so how do we optimize convex functions? If you can think back to high school calculus, if we have a parabola defined by y equals x squared, how do we find its minimum? Well, it's pretty simple. You just find the first derivative and you set it equal to 0 and solve for x. So in the case of a parabola, x equals 0, or in the case of this particular parabola, x equals 0. So we can essentially do the same thing with our minimization problem, right? So we have this convex function. We can minimize it out of the box. The problem is we have a couple constraints that we have, right? If I hop back a couple slides, you can see we have the sum constraint and this non-negativity constraint. So we have to find a way to take these constraints into account when we optimize as well. So the way we handle the sum constraint is using something called Lagrange multipliers, and we could basically use that to move the sum constraint into the objective function. And we take the derivative as before and set it equal to 0 and solve for omega ij, and this gives us the formula that you see here. So roughly speaking, I know this is like quite a lot to look at. So this formula is taking into account not just the signal on a particular subgraph, but also how much other indexers have allocated to that subgraph. And the amount and how it takes the other indexers into account is a function of the square root, which is quite interesting as well. And then we also have to deal with the non-negativity constraints, right? We have two constraints, sum constraint and non-negativity. So using dualization, we can push both constraints into the objective function. And then using the KKT conditions, we can use the same process of setting the first derivative equal to 0 to solve for the dual variable v. And once we have v, we can use that to solve for omega ij. And this is actually what our code does. So notice a couple things about this optimization problem at this point. We're not taking into account in this part of the optimization anything to do with gas. We're not taking into account anything to do with indexer preferences, whether they would prefer to reallocate or prefer to hold on to existing allocations. We're not taking into account anything about indexer's own sort of operational costs or things like how much time it will take to sync a particular subgraph. This optimization is purely done over the indexing reward. And so when we talk about optimization in this context, at least for now, this tool is only thinking about the indexing reward. It's not considering optimal with respect to anything else. So with that in mind, how do we incorporate gas costs? So we do expose a way to incorporate gas costs. And basically what that will do is it'll do the normal optimization problem that we talked about, and then it'll brute force a solution with the gas cost. So we can't guarantee optimality with that because, again, it's a brute force thing. It's not actually based on any sound mathematics. But in practice, it does seem to work probably like to within 5% of what's actually optimal. Would be a pretty safe bet. So we can't guarantee optimality, but in practice, it seems to work well. In the future, going forward, we do actually plan to push the gas cost into the actual optimization problem. So then, when indexers use this tool, they will be allocating optimally with respect to gas as well. Okay, so how to use this tool? So first of all, the tool is on the Graph Protocol's GitHub repository under allocationopt.jl. And there are instructions here. We also have instructions in the GitHub repo as well, so I'm not going to read through it here. I guess I can quickly demo in case none of you have used Julia before. All you have to do is you open up the Julia REPL from the project root, so you can see I'm in allocation opt.jl. You activate the environment, so that loads all of the packages that we're using. And then you say using allocation opt, which is the allocation opt package. And then the function that we expose is just indexer, optimize indexer, sorry. And I'll just use one that I've run in the past just for sake of demonstration. But that's pretty much it. So for now, the only way to interact with this tool is via the Julia REPL. Hopefully fairly soon, we plan to integrate this with the action queue that Ford's building. And that will provide sort of a nice GUI front end to using this tool. So you won't have to deal with the Julia REPL at that point in time. So yeah, this is sort of what you get. I won't get too much into that right now. And again, just as a warning, we don't yet recommend using this tool for indexers just because of a few bugs. So next steps, we want to add front-end GUI via the action queue, like I mentioned. We want to incorporate more tunable indexer preferences. We're going to start explicitly optimizing over the gas costs. We're also given some advice by Chris that the option, he would like the option to freeze certain allocations such that there won't be considered in the optimization process. And currently the optimizer also only optimizes at a fixed point in time, whereas it might actually be beneficial for indexers, for example, to not allocate some GRT and allocate it later. So there's some time domain component that we're not yet considering in the optimization problem. And potentially, eventually, we'll also get to optimizing over time. That's it for me. We also welcome any suggestions from indexers or anyone. So if you want a particular feature from us, just let us know, submit a feature request on the repo. But that's it. Thanks. If there are any questions, I'm happy to answer.
I have a question. I really like how you explain the tooling and how much thought is in it. I would love to have a benchmark against the existing allocation optimization toolings, because it looks like you put a lot of effort into it. And another thing we encountered by using the allocation tooling developed by AnyBlock Analytics was all these toolings are great, but in practicality, we need to also optimize for syncing times. If you get new subgraphs as a optimized result, and allocating to them can take a lot of time until they are synced, and that's something that should be incorporated in some of the toolings as well.
Sorry, go ahead.
No, that's it. Sorry.
Cool. Yeah, those are both great points. So benchmarking, I think, is definitely very important to us. We haven't formally benchmarked yet. What we have done is we've taken several indexers just randomly sampled from the graph and run them against the tool and seen how much better we can do. And on average, we're able to improve sort of from this sample of indexers, we're able to improve their indexing rewards by something around 50 to 80%, with some indexers being suboptimal enough at this point where we can do closer to around 200% increase in indexing reward. So no formal benchmarking yet, but those are sort of the hand wavy numbers I can give you through our small tests. With respect to sync times, this is something we have considered, and it's something that we want to incorporate potentially into the optimization problem. I would say for now, one of the things that we actually expose in the optimizer is a whitelist and a blacklist. So if there are subgraphs that you just don't care to sync, adding them to a blacklist as a temporary thing would be sufficient to basically say, hey, I don't even want to consider allocating to this subgraph because it'll take me 3 months to sync. So that sort of, it's not the best solution because we're not actually optimizing there. It's just basically you're saying, take this subgraph out of the optimization problem.
I have a question or suggestion. You may consider it anyhow, but I guess your program will actually great program. Yes, it's really nice to have something like this. But I guess it would suggest to allocate, for example, one GRT for a subgraph where no any other indexers or just other indexes who also allocated only one GRT. And this is how you'll get maximum rewards from this, but still anyone can enter and just ruin your proportion and ruin your indexing rewards. And it would be a great thing to include something like minimal allocation tokens, just to prevent such cases, or to allocate something that would be, you know, hard to overcome for other indexers, just like in a game theory.
Yeah, that's also a great point. So this is something we've considered as well. It's actually on our Kanban board, is to add a minimum allocation. So it's a great thought. With respect to you know, being able to react to other indexers, I sort of have two thoughts here. One is that in part this is talking about optimizing over time, right? You want to be able to do sort of these you mentioned game theory, more game theoretic predictions about what other players in the space will do, and then sort of preempt them in certain ways, or such that you can still, you know, keep the reward that you expect. So we do have some thoughts about how we would allocate optimally over time and how we would bring this time domain components in, but we're certainly not there yet. The other thing that we have in mind is, at least sort of as a short-term thing, what we might do is we might have it such that the optimal allocation tool runs for indexers at some frequency, and then, you know, it'll alert you or it'll ping you if there's some opportunity because some other indexer has moved. So again, that's not a perfect solution, right? Because it's not truly optimal in any sense. But what it does do is it gives you the ability to react when you're no longer in a favorable, you're no longer allocated favorably to yourself.
And also one more question or suggestion again. Every indexer currently has some allocations on subgraphs, and they question whether should they reallocate them for better proportion to optimize it, or keep it as it is because it would provide more profit in a certain amount of time. For example, in 10 days, maybe the current allocations would give more GRT because you will spend much more on gas. But in, for example, 20 days, the new, more optimized solution would provide more GRT. So I guess the nice outcome would be how many days would it cost to overcome the costs, the gas costs, and how much indexer will get from this more optimized allocation.
Yeah, great point. So one of the things that Hope has implemented is something that we call the, well, she's implemented two things, but one of them is the preference ratio. And if you specify the preference ratio when you use the optimize indexer function, essentially what it tunes is your willingness to reallocate versus how much you want to just hold on to existing allocations. So there is a way that using the optimize indexer tool that you can actually tune your preferences as per, or tune sort of how the tool operates as per your preferences. Of course, once you do that, you're no longer optimal, right? Optimal is optimal independent of your preferences. But definitely we want to be able to support, you know, we understand that, you know, optimal, we're dealing with optimality in a sandbox. Indexers have a much wider perspective. And so we want to be able to support that indexers can use their preferences to push the tool in one direction or another, even if it brings us further away from optimality.
Yeah, thank you for your answers. I'm sure I'll be waiting for all these plans and improvements. Thank you.
Thank you.
Yeah, thanks, Annie. Guys, if you have more questions, maybe you can follow up in the forum. In the interest of time, we should move on, I guess. So Adam, I think Adam is a nice demo for us as well.
A nice demo remains to be seen. Yeah, I guess there are two things that were on the list today. So one was the epoch block oracle. So we spoke about this, I think a couple of months ago. This epoch block oracle is maybe a slightly cryptic title. Essentially, it is a key sort of piece of protocol sort of infrastructure that will now enable indexing of not just Ethereum mainnet subgraphs on the network. So it's really providing that key piece of information, which is like which blocks should I be closing my allocations against for networks that aren't Ethereum, which is that the major blocker. So yeah, so the GIP was posted. The GIP is actually slightly behind some of the implementation which has been going on, which is great. There's been a lot of work across a few fronts, both from the data edge side. So Zach did I think had a separate GIP on what a data edge is, basically a really efficient way to store data on chain and then have the execution of chain that's being manifest for the first time in the epoch block oracle. So great work from a whole bunch of people, including one who's been turning core data on chain into a meaningful subgraph, and then Flivo and Tiago from Edgenode have also been working on the more operational, what will actually take to have that thing running on an ongoing basis, which I think is often the detail that can get lost when it's coming to these protocol facing GIPs of what are the operational impacts of running this. So I'd encourage everyone to take a look at that. Obviously, being aware there's a lot of work going on as we speak, but certainly be good to get different people's perspectives. We obviously made some trade-offs in the design of that GIP and the overall system, but we're super excited because it does unlock such enormous potential value in having not just mainnet subgraphs on the network. So I'll pause there. And I guess the other thing, and unless there are any specific questions about the epoch block oracle, I did the classic thing of posting it with only a couple of hours before the meeting, so nobody could read my homework before we showed up. So sorry about that.
Yeah, I just posted the link to the forum as well, where you have some nice discussion. And what I'll do is I'll just share also your intro you've done in the previous core dev call. I think there was the call number 10. So I'll just post a link here as well if folks want to they just want to watch a quick intro.
Cool. Awesome. Then I think the other thing on the agenda was kind of at the other end of, I guess, of Graph Node's sort of considerations. There are obviously the network considerations, but it was about the Graph client, which is really at the sort of developer experience, DevX sort of focus of Graph Node, and this is an area where we've also, I think, been making a bunch of improvements. I think the Guild have presented recently. We're obviously working on Graph client. Graph hard hat is similarly a thing which we hope will make developers' lives easier. So I kind of just wanted to demo a couple of things. So caveat always with demos. What I kind of want to highlight here is just some of the developer experience things that are already happening. Some of the things like the reason why hard hat plugin might be really useful. And yeah, maybe it'll all fall over. So let's see how we go. What am I running here? If I give myself a chance to see anything. Perfect. So I'm running the latest build of Master. I'll talk about why that is in a second. I'm running a local chain, and I'm running a local app just because if I move this up here, that's maybe going to give me the best chance. If I make everything smaller. I guess the first thing I want to kind of highlight is a new feature which has been really long requested, which is orthogonal to the Graph hard hat client, but it's effectively the fact that you can as of the latest build and not yet released but coming soon, you can access information about a receipt during a mapping as well as information about the transaction. So if we jump to here, that's the epoch block oracle. Previously, you had the transaction information, but you didn't have access to the receipt, which has a load more information in it. And this is really good where you can't So the receipt, essentially, it's surfacing more information for developers. The sort of information this includes is like most saliently the gas used on a given transaction, which wasn't available. So we had people who were trying to track the gas used by their app, and obviously that has a big impact for users. So they can access that. You can also access other logs as part of a transaction. That were part of.
Adam, we can only see your code. Sorry, I think you're pointing to something that we're not seeing. We can see. Yeah, I see your mouse going around, but I think you're highlighting stuff that.
Okay. Yeah, we're looking.
Yeah, exactly. Now we can see.
Yeah.
Now we can see the browser and the whole receipt.
Awesome.
Perfect.
Thank you for that. So yeah, so we're essentially have more information. Like most certainly, there's logs, which essentially super relevant for NFTs who maybe want to track a sale, and so they want to know the other things that have happened in the same transaction. So it's unlocking more functionality. In terms of what it takes to enable that on a subgraph, it's pretty simple. Essentially, on the event handler, you actually just say receipt true. The reason why we're not passing receipts to everything is that there is an additional RPC call to fetch this information. But then once you've got that, then within your source code, you can get the information about a receipt to and save it. So here we're essentially adding the gas used for like a purpose type transaction. The broader thing that I wanted to kind of demo here, so we'll have a look at that in action. I think you can kind of see it in this. You can actually see the gas used for this given transaction, and I think this one should probably be the same. Maybe. Now if we give that a second, yeah. So that one slightly different. I suppose it's different gas. This is new functionality which we're excited to see. Like there are some nuances in accessing stuff, but I know Simon has been keen for this for a while, so we're excited to have it out there on the hosted service in the latest alpha version of GraphJS and GraphCLI. Anyway, oh, there's my music, fantastic. So then the next thing that I want to highlight is the essentially the overall workflow, and I'm conscious of time. So if folks want to drop off, no hard feelings. I want to kind of demonstrate the workflow that we want to really improve with the Hard Hat Graph plugin. So firstly, like if I'm developing a contract, I might essentially change something here. So maybe I want to not have this log. That should actually reduce the gas cost, the gas price for this transaction. So maybe I want to then deploy subgraph. So give that a second, it'll compile. So that's deployed to my local network. And so a few things here. So firstly, I'm working in this Hard Hat repository here. One of the key things is that I've deployed a new contract, so I've got a new address, and passing that into my subgraph is a bit of a hassle. Like copy pasting between those things isn't that ergonomic for a developer. And so the first thing that we've kind of put in place as a precursor to the Hard Hat stuff is this networks.json file, which essentially is updated or can essentially be passed directly into the subgraph.yaml. So if you essentially update this, then you can update the YAML file. So it sort of simplifies that loop. So the current workaround that's in my local development setup is that when I deploy, I've got a post deployment script that updates this file. The Hard Hat deployment, the Hard Hat Graph plugin could essentially automatically do that. It would be sort of aware of where it needs to push the new contract information and where it should go. And so now if we go back here, and if I go and I think it should just actually be build network localhost. Hopefully this 9EF thing should jump into the subgraph. Yeah, so you can see that this address was then updated. So that was because if here you can see that I've passed this flag saying network localhost, so it knew to use the localhost. There's only one network here. If I had more time, I was going to deploy to Kovan and then do the automatic update, but you kind of get the idea. The Hard Hat plugin will then make that even tighter, so developers don't have to do that sort of plumbing themselves. So it can really streamline the developer experience. if I then deploy this again, I guess here, giving this a chance, the file that then deploys to my local graph node. You can see it starts indexing. Now, if I refresh this one, firstly, we go here, purposes, and look at ID, purpose, gas used. There's nothing yet because I haven't actually made any transactions. U1. Now you can see that if I do this, that first gas user, I think that was actually a bit cheaper than before. If you've got a memory for like precise numbers, and I think that's because we removed the console.log file. So anyway, that's hopefully giving you a sense of the developer workflow that we're trying to improve and make more streamlined. I'm highlighting this new feature. Yeah, I think this was great work by Tiago. And so excited to see that and excited to see what people build. But yeah, conscious of people's time, we're a couple of minutes over. I'm happy to hang around and answer questions, but also want to let people head off if they've got 5 o'clocks.
Is this live already on the hosted service?
It is. You've got to use the alpha version of GraphTS and GraphCLI.
Yeah, because I already kind of showed this to another developer, I think 2 weeks ago, and it was not possible yet. But then, yeah, I will follow up. Like the guys from Art Blocks are really waiting for this feature.
Awesome. I think there's some nuance on how you decode the logs for the other events which we talked about. But I'm sure Eva will be happy to help us with that sort of particular ABI decoding challenge. So anyway, that's enough.
Pretty cool. Nice, thanks, Alan. Yeah. Also, shout out to LimeChain who's been leading this work on the plugin development itself. All right, cool. So it's going to be recorded. You can watch this at a slower pace, maybe on YouTube if you want to. And I guess we can wrap it up here. Thank you all for joining. I'll see you on the next one. It's going to be on the 26th of May. Again, do subscribe to our ecosystem calendar. Just head on to the Graph.Foundation. You'll see an ecosystem calendar link. Just subscribe, please, so you don't miss any of these in the future. Thanks all. See ya.